So now you know how to start the scientific process, come up with an experiment, run the procedure, but now we need to know exactly how to record the information that we're needing to gather during that procedure. And to do that, we need to know how to set up a data table, turn that information into graph, and further analyze the information using mathematical analysis. So the first step in all of this information organization is creating a data table. So first off, what is a data table? And it is a simple, easy way for people to look at the information that we've gathered. So we want our audience to be able to quickly identify information in an organized fashion. Usually that's going to be the quantitative observations that we've made. Sometimes, however, we will include qualitative observations on a data table as well. Once we've recorded that detailed information in an easy-to-read table, we'll oftentimes create pictures or graphs to help us analyze that information later on, and we'll get to that in a little bit. But first, we need to look at the specifics for making a data table. So there's some key parts to setting up a data table to keep in mind no matter what data table you're creating. And the first one is making sure that you've labeled your table with a title and a number. Sometimes you may run an experiment that includes more than one table, in which case your label right here would say Table 1, the next table would say Table 2, and then Table 3, Table 4, and so on. You need to make sure that you include a title on every graph that you create. Your title is what is going to tell your audience what the information is talking about. So in this case, the title is telling us that temperature is having some sort of an effect on the height of sunflowers, or at least that's what they were looking at. So once they've created their data table to show us what the temperature is how the temperature is going to affect the height of sunflowers, they've included their independent variable off to the left and our dependent variable off to the right. In this case, our independent variable, or the thing that they've chosen to look at, is temperature. And the thing that they're measuring, or their dependent variable, is the sunflower height. We know that it's temperature in Fahrenheit because the author has included their units in their column headings. They did that instead of putting it in the cell so that the cell is easy and clean to read. They did the same over here when they were looking at the height of their sunflower. We know that they measured it in meters, however they didn't put it within every cell so that the cells are easier and cleaner to read. Once we've created our data table, we need to keep in mind a couple of key things. One, remembering to keep that data table with a label and a title, but also to make sure that we create that data table before we start our experiment. If you don't do it before you start your experiment, you risk missing key pieces of information. If it's done before your experiment, now you have a specific place that you can record the data as your experiment is being run. And if you're trying to quickly fill in what your data table may look like as your experiment is being run, you might miss some important and critical information during your experiment. Again, making sure that we're keeping it nice and clean by putting our headings, our units within our headings, not in the individual boxes. And then to keep it in the same format, our independent variable to the left and our dependent variable off to the right. But oftentimes a data table isn't all that we need when we're creating information to pass along to an audience. A data table is fantastic for showing our audience specific information in an organized fashion, but sometimes our audience simply wants to see the pattern that our information created, in which case a quick picture is going to give them exactly what they need. And that picture is going to be in the form of a graph. And a graph is going to have the same basic information, but again, maybe not quite as specific. So again, some of the key parts are going to be the same. We need to have a label with a number and a title. We need to include our independent variable and our dependent variable. And then we also need to make sure that our units are labeled on our axes. Our independent variable, if we're making a bar graph or a line graph, is going to show up on our x-axis. And our dependent variable will always show up on our y-axis. And then the picture will show up in what's called the plot. And that plot always needs to have a key so that our audience knows exactly what they're looking at. For this experiment, the effect of time on temperature of water after adding an ice cube, the author decided that the information that needed to be conveyed was only the average of all of their data that they may have collected. And so they showed in this picture how the water changed in temperature on average over the course of 90 seconds while running their experiment. So some reminders for important tips in creating a graph. We want to make sure that our graph has a label with a number and a title so that everyone knows exactly what they're looking at. We also want to make sure that we're creating the right type of graph. And there's three main types of graphs. The first type is a line graph. We're going to use a line graph when we're showing a change over time. And we know it's a change over time if time shows up on the x-axis. The second type is a bar graph. And we'll use a bar graph whenever we're comparing groups or individual items on the x-axis. And the last one is using a pie graph when we're showing percentages or parts of a whole. For example, 50% out of 100 of the students liked going on the field trip. We also want to make sure that we're putting those units in our axis labels so that we're not cluttering up the plot or the picture of the graph. We want to always make sure we put our independent variable on the x-axis and the dependent variable on the y-axis. And finally, we need to make sure that we're creating a key so that our audience knows what the picture is showing them. Aside from using data tables and graphs to convey information, we sometimes also need to include some mathematical analysis that will either help us create our graph or analyze the information that's on our graph. And there's three main types of mathematical analysis that we'll use. The first type is finding the mean. So the technical definition of the mean is the sum of the values in a data set divided by the number of the data values. So essentially this is the average of your information, where you take all of the data that you have, each individual data point, and divide it by the number of data points or the number of numbers that you're working with. For example, if I was running the ice cube experiment from our graph on the previous page, I know that my data points are 22 degrees, 15 degrees, 7 degrees, and 5 degrees. Since I have four numbers, I will add those numbers together and divide by 4. So my total is 49 divided by 4, and my average ends up being 12.25. So the mean, or the average, is 12.25 degrees Fahrenheit. Another mathematical analysis I might find useful is knowing where the middle of my data set is, and that is called the median. The middle number of our data set, when we put all of our numbers in numeric order from least to greatest or greatest to least, is the middle of our information. So in order to do this, you line up your numbers from smallest to greatest or greatest to smallest, and then you find the middle. However, sometimes you have an even number of data sets, and so then you have to find the average of your middle numbers. So for our ice cube experiment, we had four numbers, 5, 7, 15, and 22. So the two middle numbers were 7 and 15, since there's no exact middle number. So then we need to average those two numbers. So we take 7 plus 15 and divide it by 2. So we have 22 divided by 2, which gives us a middle or median number of 11, even though 11 wasn't one of our actual numbers to begin with. And the last type of mathematical analysis you may use when working in experiments is finding the range. You may find it useful to know what was my smallest number and my biggest number while working on this experiment. And so it's essentially your spread of data. So to do this, you find your smallest number or your least value in the data set and your greatest value in your data set, and that's the range. So the smallest number or the least number in this case was 5 degrees Fahrenheit, and the greatest number was 22 degrees Fahrenheit. So in this case, the range of our temperature was 5 to 22 degrees Fahrenheit. So in summary, this is how we might use the information that we've observed during an experiment. We first need to record the information in an easy-to-read data table so that our audience can go ahead and find that information quickly and easily if they need to. We may also find it useful for people to be able to see what kind of a pattern is created in picture format by creating a graph of our information. And we also may find that we need to find some mathematical analysis of our data by using either the median, the middle number, the mean or the average, and the range, the spread of our data from smallest to greatest.